Okay, so we're going to start with the common rafter on the main roof. We can start either with the common rafter on the main roof or the common rafter on the L roof. It really doesn't matter. But actually, technically, we do have to start on the main roof because we don't know the slope of the L roof. So we've got to start on the main. This is 812 and it has a 36-foot span. We're looking for what? Two parts of this? Height and the length of the common, right? To get the height, we know that this is 18 feet. So it'll be 8 over 12 equals h over 18. Cross multiplying and dividing. 8 times 18 divided by 12 gives us the height is 12. So 12-foot height. So then we're going to find the length of the common here is going to be found by doing the square root of 18 squared plus 12 squared. $21.633. So that's this right here, 21.633 feet. Now what? Yeah, now we can use that for the common on the L side. We don't know the slope, don't need to know the slope. We know the span is 24 feet. And we know that the height has to be the same as the height on the other side, or 12 feet. This run, of course, is 12 feet. So the length of the common rafter on the L side will be the square root of 12 squared plus 12 squared. $16.971. As I'm cheating. So that's this right here. Is 16.971. It's a shortcut. If both legs of the triangle are the same, you can just multiply one of them by the square root of 2 to get the hypotenuse. So now that we have the common rafter on both sides, let's look at the L side here first. What's this length right here going to be? 18. So when I construct that triangle, this is 18. What goes down here? 16.971. Good. My next triangle, which is going to come right here, what's this distance going to be? 16 feet. Where'd 16 come from? 18 minus 2. Very good. So we'll call this X. What's the proportion I'm going to set up? 18 over 16, yep. Perfect, 16.971 over x. We can cross multiply and divide. 16.971 times 16 divided by 18. 15.085. Correct? That's our next longest, so now it is simply going to be 16.971 minus 15.085. 1.894 feet is our difference. Correct? No.
No, I got
1.886. That's on the L side. That's the decrease. Now we need to do the main roof side. So over here, what is this length right here? That's 12, half of the 24 feet. So we have that triangle. 12 feet, and this was the 21.633. On this next triangle, Yeah, we'll draw this in here and it'll be 10. You're right. And we'll call this y. So 10 and y. So our proportion will be perfect. Cross multiplying 10 times 21.633 divided by 12. 18.028. So we shall have 21.633 minus 18.028, which will give us 3.605 feet. Yes? 605 is what I'm coming up with. There you go. There's a cross multiplying for the L. Yours may have came up slightly different because I just used the number that was already in the calculator instead of punching back in 16.971.
I did it just opposite. I used the wrong, like the 16.971. I used the 21.
Oh, gotcha. Okay. Anybody feeling absolutely, completely, and totally lost by this?
I'm just happy I did that subtraction problem almost as fast as you did, so
cool.
That's an accomplishment.
That's a start. In your, actually on a separate sheet of paper to turn in, so for this one, actually for both of these, find both main roof and L roof decreases. The hip or the valley jack decreases for both. It is time to move on to our next step. What we are going to discuss next is we're going to discuss stairwells. Several features we're going to define here for us. First, before you even put in a stairwell, you have to have a stair opening. And of course, there is a floor thickness that needs to be considered in all this. When we say floor thickness, unless otherwise stated, we are going to assume that it includes the ceiling on the lower floor, any floor joists, any subfloor, and any finished floor. So it includes everything from airspace to airspace, basically. And then, of course, there will be a lower level ceiling height. We're just going to refer to it as ceiling height, but it is always going to be referring to the lower level. The upper level ceiling height doesn't matter because the stairwell does not traverse that way.
It's going to be like a giant triangle.
Kind of. So then from there, our stairwell goes down. Pretend that my drawing doesn't suck. Now we have, yeah, the computer rounds it off on me. That always sucks. But anyway, what you guys have known as the riser we will often refer to as the unit rise. Common term, what I usually refer to it as the riser height. So I'll use either term depending on what mood I'm in that day. Then what's commonly referred to as the tread width is often going to be referred to as the unit run. Another important quantity goes from the edge of the stair opening down. Now, there's debates on how this is supposed to be measured, and it'll depend on what building inspector you go to, or what building inspector comes to you, I should say, because you're not going to take your stairwell to them. The way I understand it, the way I've interpreted it in recent years is different than what it was it changed about 12 years ago. But there's a plane that goes from nose of step to nose of step like this. And that head clearance is measured to wherever a plumb bob hung from that edge of that stair opening would touch that line of sight. Head clearance. Sometimes it's just called the clearance. Now, there are some building inspectors that actually interpret that to be the distance to the tread that is located directly beneath it, as long as it is more than 3 inches away from the nose of the next step. Does that make sense? If it's within 3 inches of the next step, they interpret it to be off of that next step, which is the old way of interpreting it from like the year 2002 or 2003 is how that used to be interpreted. But as long as it was more than 3 inches away from that step, you went down to the one directly below. If it was within 3 inches, you went to the one above. So you may run into that with some building inspectors. Like I said, the way I interpret it now, it's supposed to be off that line, the nose line. Any questions? Okay. Now, in order to design a stairway, you guys have probably been taught the 7-11 for stairways. What is your allowed variance off of the 7? Have you been taught that yet? Your allowed variance off the 7 inches. Just getting that? Usually it's plus or minus a ½ inch. It used to be the rule of 18 for stairways. Your unit rise plus your unit run had to add up to 18. So you could do an 8-10 or a 9-9. Your minimum tread width was 9 inches. So you could do a 9-inch riser and a 9-inch tread. That gives you a pretty steep stairwell. It's not so bad. It's actually fairly comfortable going up, but it's not very comfortable going down, because your heel hits the step and your toes don't. So you find out to be comfortable going down, you end up turning sideways on them most of the time. So they've gone away from that. I believe your minimum tread width now is 10 inches, if I'm remembering correctly. Is it still 9? Is it still 9? Okay. They try not to. I know they were talking about changing it. I know you can still have a 9-inch rise in certain applications, but you can no longer, in commercial applications, you can no longer have an open toe. Like the stairwell on the other end of the building over here by the bookstore that goes up. That is no longer, if they ever do anything with that, they will have to totally redo that, because there's open risers there. You can't have that open anymore. That has to be enclosed. That used to be very common in the 70s.
Yeah, my grandma used to live in a place next time up the back of the stairwell.
And it was always like that. Mm-hmm. A lot of banks that had basements had the stairwells like that. Also, you go into a lot of banks and a lot of commercial places, the stairwells had 6-inch. You had the steel spindles, and they were 6 inches apart. And they're all grandfathered in, of course. If they ever touch them, they've got to go back to 4 inches. You still don't see too many kids with their heads stuck in the stairwell at the banks. But anyway, so first thing you have to be able to find is you have to be able to find the total rise. Total rise is just going to be your ceiling height plus your floor thickness. Remember, we're assuming the floor thickness includes everything. It's lower ceiling, joists, subfloor, and finished floor. So let's say we're in an application where we have a 13-inch floor thickness. What is our ceiling height generally? 8 foot 1 1/8. But that 1 1/8, that's unfinished ceiling, right? That's allowing for 5/8 inches of sheetrock. So generally be an 8 feet and a half inch. The floor thickness includes the sheetrock of the ceiling below, the floor joists, the subfloor, and the finished floor on the upper level. So I mean everything from airspace to airspace. So here we have 13 inches. 8 feet is going to be converted into 96 inches. So that lower ceiling height is 96 1/2 inches. So this adds up to 109, and I'm going to change it to 109.5 inches is our total rise. You have been told to always assume a unit rise of 7. There's some places that say 7.5, which is silly, but used to be you could round up or down a little bit. They're saying now that they don't want you to ever go below 7 inches. They'd rather have you above 7 than below. So the first thing we're going to do is we're going to estimate the number of rises. The number of rises is going to be found by taking the total rise divided by your estimated or assumed unit rise. So here it's 109.5 divided by 7. So 15.64, 28571428, yeah. So it's 15.643 rises. Now let's talk about this number for a second. Obviously you can't have part of a rise. So we're either going to have 15 rises or 16 rises. Now this was assuming a 7-inch unit rise. If we make it only 15 rises, will the unit rise be more or less than 7? Slightly more, greater than 7 inches. If we go 16 rises, it'll be slightly less than 7 inches. Now, have you guys talked at all about whether you'd rather be over or under on your 7?
You just said you'd rather have it.
Yeah. Generally accepted, architecturally speaking, it's usually generally accepted you'd rather be over. So which one do we want to use? 15 rises. As long as it doesn't throw you over 7.5 inches, you should be okay. So what that means now is we're going to go back. Now that we've found the number of rises, we have to find now the exact unit rise. And we do have to be very, very careful here. Does anybody know how many rises are usually in a standard stairwell? 13 to 15, depending on your ceiling height. That's why 13 is considered to be an unlucky number, by the way. Yeah. Well, it used to be, falling down a stairwell was unlucky, so there used to be standard 13 rises. So that's how it became an unlucky number. But anyway, we know if you're off by, let's say, a 1/16 of an inch.
If each stairwell is going to be off by this.
Yeah, if each tread will be 1/16 of an inch off, at 13 rises, that's over 3/4 of an inch. So you get to the bottom step or the top step, you're going to be 3/4 of an inch off. So I mean, even being off by a 1/16 of an inch is too much. You have to make this calculation very, very precise. So our exact unit rise is going to be still our total rise divided by our number of rises. So that'd be the 109.5 is still our total rise divided by 15. So 7.3 inches exactly. So that is 7 inches. We're going to take the 0.3 times 16 will get you to a 16th. 4.8, so that's 5/16. So 7 and 5/16. Now I just said being off by a 1/16 of an inch is too much. Why did I only go to the 16th and not the 32nd? Well, going to the 16th, the furthest we can be off is half of the 16th or a 32nd of an inch. So hopefully we're not. It could be a problem. This one came out to be 4.8. So it's not a huge issue. So you're only off by 2/10 of a 16th or by 1/80th of an inch. So that shouldn't be an issue. But if it were like 4.5 or 4.6 or 4.4, where it was really close to being halfway in between, then you'd want to reconsider maybe going to the 32nd, because then you could be off by 3/8 of an inch by the time you get to the bottom of the staircase. So anyway, that is our unit rise. That's our exact unit rise for this staircase. Now I'm going to keep this 7.3 inches because we are going to use that for our calculations later on here. Unit run. Good question. Unless otherwise stated, that will be 11 inches. That's what you assume it as. So that is the first part of the journey, is figuring out what the exact unit rise has to be. We are a little bit past our break, so let's go ahead and take our break. Let's start up at 10:34 again.